So the bulk of the next stage of our work is going to be removing these wires, getting proper connections from the pins to go into the appropriate locations on the ArduPilot, basically the same pinouts routed to different input ports depending on which is the throttle and which is the steering and which is the aux or flight mode port that we set in the software. We'll download that latest firmware that we can use. It's an 8 megabyte controller, which is limited to only version 3.4.06, I believe. It won't handle the more modern 4.0 firmware updates. But it's certainly all the necessary software to fully automate this buggy into a navigational GPS-driven, waypoint-driven system. Cheapest way to go, and then later we'll use one of the more modern Pixhawks to gain any additional capability we want, like a drag parachute or whatever we want to set with one of the servos. Now the primary task is building the wiring, building the harnesses, getting another BEC controller installed, hooking up into the existing battery cables. We'll tap into that for the BEC and for the power system to connect to the computer. We'll rewire the servo wire into the computer, and we'll rewire the throttle wire into the computer and rewire the LED into the computer, and we'll have the computer control all of that, plus additional aux switches and mode switches. And then the last thing that'll take some time is we'll have to hook up the GPS to both the I2CS port that you see, I2C port, and the GPS port. It'll take a 5-pin connector and then a 6-pin connector for those, typically split on a 3DR GPS, or we can use the old version, which is a 6-pin pin out, depending on which GPS module we want to purchase. This particular controller will not handle a CAN bus, so the new next-gen GPS systems that typically run either the GPS, I2C, or CAN bus is not installable on this ArduPilot. And basically the only thing you give it up using the ArduPilot is it does not have any storage, onboard storage for logging systems. You're just going to have to log everything through a telemetry radio that we install over in the telemetry port. And that's only one telemetry, so any video transmitter system, camera system, and OSD overlay screen that we're going to build for it will have to be spliced into one telemetry UART instead of two, which is typically available on the Pixhawk. In addition to that, we have to wire directly to this receiver. We won't have to use a PPM converter like we would if we were wiring up to a Pixhawk or wiring to the Pixhawk. We could use a remote receiver, which would be one of the remote spectrum transmitters that would be a 6-channel, which we've done before when we hook up any Pixhawk system to one of these 3-channel systems. Mostly the ArduPilot APM can bypass some of those little additional complexities that will come from wiring up a spectrum receiver to a port that doesn't have the little SPM/DSM, DSMX independent port, and doesn't require a PPM converter. So it's kind of nice feature on these older models to just wire direct to the receiver, input and output, instead of having to go through that serializer. It does not have S-Bus capability and doesn't have serializer capability. We don't get that till we upgrade to the Pixhawk 1 or the Pixhawk 2 Cube.